So let's start EMCO Milling Machine. First, we will start with some fundamentals. In order to operate this machine, CNC machine, we need to understand what is the reference point. Without understanding this reference point, if you operate the machine, then the measurement will be wrong. Tool will be hitting with your workpiece, or workpiece will damage. So this milling machine reference points, first one is NT, that means NT, then M means machine 0 point, then W means workpiece 0 point, and R means that is the reference point. So what is machine 0 point? Machine 0 point M is an unchangeable reference point defined by the manufacturer. We cannot change this point. This is the origin of the CNC machine. So here we can see this point. This point means the bottom left side of the table. That is what is called the machine 0 point. So this 0 point is unchangeable reference point. We cannot change this. So this is the basis of CNC machine. That means this point will be 0, 0, 0. We can say this will be the zero origin of this machine. So whatever movements we will take in this machine will be from this origin. That is what is called a machine 0 point. User cannot change this point. So this will be the actual origin of the coordinate system. So this is very important, okay? Then coming to the next one, workpiece 0 point. So workpiece 0 point means this is our workpiece, right? The workpiece 0 point W can be freely programmed by the user. That means the operator can select a reference point. The operator can choose. For example, if this is the workpiece, the operator can choose this one, this one, this one, anyone, anywhere. The operator can choose a reference point is what is called a workpiece 0 point. So when we write a CNC program, in the CNC program, we will use an origin. So this origin is this W, not this machine 0 point. So that is the first important point. For example, you have a workpiece like this. For example, you have a workpiece like this. So you have a workpiece like this. Say this is an aluminum block. Okay. So I can fix this as the W, workpiece 0 point. Okay, so that if I'm going to machine this, so I can give, say, this is X50, this is Y50, again, this is X0, this is Y0, like that, right? So I can program this part very easily with the help of this workpiece 0 point. So the use of, when we write the program, we will not use this M. We will use only this workpiece 0 point. make sure that so that our programming will be very easy. So whatever program we will prepare will be based on this program, this reference point, workpiece reference point. So the program will be based on this workpiece 0 point. For example, say my code is like this: G54, X20, and Y30. So what is the meaning of X20? 20 mm from this W, not from this M. That means this 20 mm to the right side from the W and 30 mm front from W. So the main point is that uh, this M is fixed. Okay, this will not change, but this W is not fixed. We can change this W. This W will change, but this M is fixed. This M is fixed. Then coming to the next one, that is NT. So this point NT lies exactly the cutting point of the spindle axis. This is the cutting point. That means the center, the cutting point of the uh, spindle axis. Lies exactly at the cutting point of the spindle axis with the front part of the spindle milling spindle. This point is the start point for measuring the tools. So this plane is used to measure the tool length. For example, for example, I have a tool of length 95 millimeter, and I have another tool of, say, 120 millimeter. So the machine don't know what is the length of, so we will be using different tools. So the length of this tool will be based on this NT. So we will use this. We will use this NT to measure the length of the tool. See, next is our reference point. So next is our reference point. So reference point is firmly defined on the machine which is used to calibrate the measurement system. The reference point must be approached each time after the machine is switched on. When we will turn on the power of the machine, it will go to a point is what is called a reference point. We call it as home position, machine home. Why this is required? Why this is required? Because this machine encoder don't know where is the machine. So the machine will go to the reference point R, and the control system will reset its position. Otherwise machine encoder don't know where is the position of the machine. So after doing this referencing R, okay, so machine don't know where is the machine 0, then where is the tool, where is the table, everything. So machine then knows each and everything after doing this referencing. So once you will turn on the machine, the next step is to do the referencing or home position. Then only we can start the programming. So based on the model, based on the type of the model using, the reference point will vary. So if you use a particular machine, you should use the operation manual. The final word from, you should take each and everything from the operation manual of that particular machine. So finally, we have different reference points. One is machine 0. We cannot change this. This is a fixed, okay? And we have workpiece reference point. We can change this point. This one, the operator can change. This point, the operator can change. This one, manufacturer already fixed this point. We cannot change this. Then tool, this one, NT. This also again set by the manufacturer. We cannot change this. Using this, we can measure the length of the tool, and R is the reference point again set by the manufacturer. The operator cannot change this. So the operator can change only one reference point. That is what is called a workpiece 0 point. So next is the reference system for milling machines. This is very important. This is a very important topic related to the CNC milling. So the reference system is used in CNC milling machine to know where is the, okay, right now where is the tool, okay? So in some cases, tool will go from point A to point B, or from A to C. How much distance the tool should travel. Okay, so to understand all those things, we need what? We need the reference system. That means with the help of reference system, we can locate a particular location. We can locate a particular location with the help of this reference system. Then we have coordinate system. So for example, we have a point, say this is a point P. Okay, so we will be using X, Y, and Z coordinates to locate a particular point P. For example, the P is where X is at a distance of 40 mm, 25, and -5. So we can locate a point P with the help of the coordinate system. So using this coordinate system, machine knows where is the current location of the tool. Then we have, Cartesian coordinate system. What is Cartesian coordinate system? This X, Y, and Z. This is what is called a Cartesian coordinate system. So we will be using this like this. So this is the X, this is the Y, right? And this is the Z. Okay. X, Y, and Z. This is what is called a Cartesian coordinate system. So this is the X. That means to the right side and left side movement is what is called a X. Okay, so this is the X, right and left. Right left movement is what is called a X. Right left movement is what is called a X. So here you can see this is plus X and this is minus X. Okay, so this is plus X and this is minus X. Okay, that means in the machine table, the machine table is moving like this. That is what is called X. Then this Y, this represents the Y axis. That means forward and backward. Okay, so this is X and this is Y. So Y means forward and backward movement. So this Y means the forward and backward movement. Plus Y, minus Y. And then finally, the Z axis. Z axis means the up and down tool movement. Okay, so this up and down tool movement is what is called a Z axis. So that means up means plus Z and down means minus Z. So this is the reference. This is the reference system for milling machines. If these X, Y, and C will intersect a particular point is what is called what is that origin, right? That is what is called the origin. Okay, so all the measurements will be taken from this origin point. Then we have our absolute coordinate system and a relative coordinate system or incremental coordinate system. So absolute coordinate system means we will measure the distance from the origin. That is called absolute coordinate system. So for example, this is my origin and this point is A. So this A is at a distance of 20 mm from this origin. This is what is called absolute coordinate system. So for example, in program, we will use G90. So G90 means absolute coordinate system, X40, Y30. That means this 40 and this 30 will be at a distance of distance 40 and 30 from where? From the origin point. This is what is called a absolute coordinate system. This is what is called a absolute coordinate system. That means from the origin, it is at a distance of 40 mm to the right side and 30 mm front side, right? So 30 mm front. Okay, so this is plus Y and this is minus Y, right? Sorry. Okay, so for example, if I type X0, Y0, so the tool will be here because this is the origin, right? And then I give X80, Y50. So that means this X distance is 80 and Y is 50. Say this is point P. So what is the value of Y is 50 from, so all the distance from this origin point 0, 0. So tool will directly go to here based on this point. Then another type of system is what is called a incremental coordinate system, or we call it as a relative coordinate system. Okay, so this is, we will not measure the distance not from the origin. Okay, so for example, the tool start from this point and reaches here, say point A. Then the next step is to go to point B. Okay, so if I am using incremental coordinate system, right now the tool is here, right? So at location B, right now this is the position of the tool. So you should give the distance to B from this point A. Okay, not from the origin. Okay. So that is the difference between absolute coordinate system and a relative coordinate. When you write the program, if you use G90 in the program, it is what is called absolute coordinate system, or if you use G91, that is what is called a relative coordinate system. So here in an incremental coordinate system or relative coordinate system, the main important thing is that the current position is treated as the reference, not the origin. Okay, what is the current position of the tool? That will be considered in incremental coordinate system. So remember the code in absolute coordinate, that is G90, and in incremental coordinate system it is G91. That is G91. So remember this right hand rule. You can think about this. Right hand rule. Okay. So your middle finger. Will be Z. Okay. And index finger will be Y, and the thumb will be X. So this is what is called a right hand rule. So to understand X, Y, Z, you can use this right hand rule. So this is very important. This is very important. So this is plus X, this is plus Y, and this is plus Z. Okay. So this right hand rule is very important to understand the axis direction in CNC milling machine. So when you turn on the machine, the next step is reference. Then after that, once you do this reference, machine knows the machine 0 point. Then after that, we have to set the workpiece offset. That means G54. Then after that, run the program. So tool will based on this is the step. That's all. So next is the polar coordinate system. So we have discussed absolute coordinate system, relative coordinate system. So next is the polar coordinate system. So where we will use this polar coordinate system. So for example, in some cases, we will machine circular holes, okay? Circular holes. Or, bolt circles. Or in some cases, some angle based on angle. So to program this type of shapes, it is very good to use polar coordinate system. Normally, in CNC machine, we will use Cartesian coordinate system, right? Normally, we will use Cartesian coordinate system in CNC milling machine. But just imagine you have so many holes around a circle. Okay, just think about there are so many holes around a circle, say equal distance. So it is very difficult to write the XY distance. So in those cases, we can use the polar coordinate system. Cartesian coordinate, we can use to define, for example, we have a point. So we can use X and Y, right? To define this point. Say X is equal to 40, Y is equal to 30. But in polar coordinate system, we will use we will use the radius. We will use radius and angle. Suppose you have a point, so we will use radius and angle. So it is what is called a polar radius and polar angle to define a particular point. So for example, RP. So RP is equal to 50 mm. So 50 mm will be the radius. And AP means the angle. That means 45-degree angle. CC represents the, CC represents the circle center. That means the origin of the polar coordinates. So, in Cartesian coordinate system, we have origin, right? In Cartesian coordinate system, we have origin, right? In polar coordinate system, it is called a circle center. This is the reference point. So all the radius and angle will be measuring from this circle center point. So let's take one example. We have a circle of radius 40 mm. Okay, and angle is equal to 90 degree. So RP is equal to 40 and AP is equal to 90 degree, right? Suppose you have a bolt circle. Okay, just imagine you have a bolt circle. 1, 2, 3, 4, 5, 6 like this. So CC, this is the CC. We have six holes, radius 50 mm. So the angle will be 0 degree, 60 degree, 120, 180, 240, 300. So if you will be using Cartesian coordinate system, you have to find the X and Y coordinates separately. But if you use polar coordinate system, you can use RP is equal to 50, right? And just you can mention the angle 0 AP, 0, 60, 120, 180. So circular arc or a parts having angles, it's better to use polar coordinate system in programming. So in that case, no need to calculate the X and Y values. So pole means polar origin. So pole represents the center of the circle center. So pole is set by entering two Cartesian coordinate system. First, we have to give the XY coordinates of the pole. For example, if pole is say X equal to 100, Y is equal to 80. First, you will define the pole using the Cartesian coordinate system. Then all the polar coordinates will be from that point, 180. So angle reference axis. So angle reference axis, angle will change based on the plane. Okay, so angle will change based on the plane. For example, G17. G17 means XY. That means the reference axis will be plus X direction. Then G19 means YZ. That means plus Y direction. And G18 means Z X plane. That means plus Z direction. So here you can see this is the XY plane, right? So XY plane, so this is the G17. That means plus X direction. Then ZX means, yeah, this one, YZ. So YC, this is G19. YC, this is G19, right? Okay, so plus Y direction. This is plus Y, right? And this one, ZX plane, that means G18 plus Z direction. So remember what is the difference between Cartesian coordinate system and polar coordinate system. So Cartesian will be based on X and Y, whereas polar will be based on radius and angle. So in Cartesian coordinate system, suppose you have 4 points, you have to calculate X and Y of these 4 points. But in polar coordinate system, we should give radius one time only. Then you have to change the angle. You have to change the angle. This is suitable for linear geometry, and this is polar coordinate system is used for circular geometry. Again, this is very important. This topic is very important to understand. What is the difference between absolute and incremental workpiece positions? So absolute workpiece position or absolute coordinate system. So absolute coordinate means whatever measurement we will be taking from the workpiece 0 point W, for example. Let's consider this as W. Whatever distance we will be using in the program will be from the W. That means workpiece 0 point. And each and every point there is a proper X, Y, Z coordinates. So we will be using, when we write the program, we will be use G90 in the program to represent absolute mode. For example, in this image, you can see you have 3 holes, 1, 2, and 3, right? And hole 1 is at a distance of 10 millimeter, 10 millimeter, X 10 millimeter, and Y 10 millimeter, whereas hole number 2, X 30 and Y 20. And hole number 3, X 50 and Y 30, right? So when you write the program, you have to represent this G90 and whatever distance. So you have to give X first one for this first one you should give X10, Y10. For second hole, X40. Sorry, this is 30, right? X30, Y20, right? Then this one X50, Y30. So all the distances will be measured from W. This is what is called absolute coordinate system. Then we have incremental coordinate system or incremental workpiece position. That means now you have 3 holes, hole number 4, 5, and 6, right? So to program in incremental coordinate system, we will use the code G91. Okay. So for example, suppose the tool need to move point number 6. Right now, the tool is number 5. So to move tool from point 5 point number 6, you should give this distance. From 5 to 6, what is the distance? Do not give distance from the origin. If you use G91, that means incremental workpiece position. So the tool is programmed to move by the distance between the previous and the subsequent nominal positions. So for example, here you can see we have 3 holes, right? Hole number 4, what is the value? 10 and 10, right? Then hole number 5, what is the value? From this point, it is 20. Then from hole number 4, it is 10, right? And hole number 6, from 5, it is 20. And from 5, it is 10. So when you write the program G91, you should, for number 4, you should give X10, Y10. For 5, you should give X20, Y10. And for hole number 6, you should give X20, Y10. So when you write the program, either you should use absolute coordinate system or you should use relative or incremental coordinate system. So this incremental coordinate is also known as what is called a chain dimensioning. So why this is chain dimensioning? Because the new dimension will be based on the previous dimensions. Okay, I hope you understand. Next is called a 0 point offset. What is called a 0 point offset? This is another main important concept in CNC programming. So 0 point offset means we have machine 0 point, right? So this point we already discussed what is machine 0 point. This point is already fixed and we cannot change this. This point is fixed by the manufacturer, and this point we can set this point. Okay, the operator can fix this point. So there is a distance, right? So there is a distance between machine 0 point and workpiece 0 point, right? So this is what is called, we call it as offset. This is what is called a offset, or we call it as 0 point offset. That means we will shift the origin from M to W. That is what is called a 0 point offset or offset. Okay, so we should understand where is the machine 0 point. So machine 0 point will be the left front side of the table, machine table. So this is the machine table, and machine 0 point will be the left front side of the machine. Okay, so you cannot write a program using this M. Okay, so that we will shift this point to the workpiece. We have a workpiece. This is the workpiece where we are going to machine this. So we will shift this point to this workpiece is what is called a offset, 0 point offset. So we will shift the machine 0 point to the workpiece coordinate system is what is called a 0 point offset. So next I'm going to discuss MCS. What is MCS? Machine Coordinate System. So machine coordinate system, MCS, means this will be based on the machine 0 point M. This will be based on M, machine 0 point. Okay, the coordinate system based on the machine 0 point is what is called a machine coordinate system. That means this point is already fixed by the manufacturer. The user will not be able to change this point. When you turn on the machine, the next step is reference return, and then after that the machine will know the exact position, and so that the machine coordinates will be ready to execute the program. Then we have base 0 point. Base 0 point. So base 0 point means if we shift from the machine coordinate system, a base shift, we will have the base 0 point. For example, pallet 0 point. So this will be used in factory automation where we will be using different pallets. Next is configurable 0 point system. So we will be using this commonly in our machine. That means we have G54 to G599. So we will be using this configurable 0 point system. So for example, if I have, this is workpiece 1, okay, and I have another workpiece. So I have another workpiece, okay. Okay, so to set this W, I will use G54 for workpiece 1, and I will use G55 to set the origin, W for workpiece number 2. So when I run the program, I will use G54 for, that means it is for workpiece 1, G55 for workpiece number 2. So next is frames, programmable coordinate transformation, or frames. We call it as frames. Using frames coordinate system, we can shift, rotate, scale, mirror using this programmable coordinate transformation or frames. Shift means you can shift the origin to a new origin. Rotate means rotate through 90 degrees. So scaling means you can enlarge or reduce the size, right? Mirroring means left to right, right? Then next is the workpiece coordinate system, W. This is very important. Okay. So if we prepare a program, the program will be based on this W. The program will be based on this W, workpiece 0. So this image is showing MCS and a WCS. Okay. So first of all, I will show you. Okay. So this is our MCS. That means machine coordinate system. This is fixed. We cannot change this, right? So this is the base coordinate system. Okay. BZS, right? Base 0 point BZS. So this is our MCS, right? Okay. So you will be clamping the workpiece here. So one workpiece here, another workpiece here. So you will be clamping your workpiece not in MCS, in a different location, right, on the table. So say, for example, so this is your WCS, right? So this is your WCS, right? So 0 point offset means from MCS to the workpiece 0 point. So this distance is what is called a 0 point offset. From M to W, that distance is what is called a 0 point offset. So this will be happening in three different parts. Okay. So first one is base shift. Okay. That means from machine 0 point to pallet 0 point. Okay. This is what is called a base 0 point system. For example, if the machine is having a pallet changer, okay, every pallet is having a reference point. Then we have a configurable 0 point offset. So from the pallet 0 to the workpiece, for that we will be using G54, 55, 59, etc. That means, for example, you have a pallet. On the pallet, you have two different workpieces. So just change the offset. We can use the program just changing the offset. For workpiece number 1, you can use G54, and the next one is you can use G55. Then next number 3 is frames. That means programmable coordinate transformation. So using frames, you can shift, rotate, scale, or mirror the coordinate system. For example, uh, you can shift the origin, or you can rotate it to 90 degree, right? So once you will use the frame, you have the final workpiece coordinate system, WCS. So the procedure will be like this: machine 0, then base shift, right? That means pallet 0, then G54, G55. That means configurable offset. Then frames, we will get the workpiece coordinate system. So that will be the workpiece 0 point. So here in this picture, it is very clear. You have two different workpieces on this machine table, right? So workpiece number 1 and workpiece number 2, right? So first, when you turn on the machine, reference return, then machine 0, then base shift, pallet 0, then after that G54, G55, then frames final coordinate system. See, in our program, X20, Y30 same, right? For example, for this one, X20, Y30, this also X20, Y30. But G54, if the tool execute G54, it will come here. If the tool execute G55, it will go here, X20, Y20, Y30, right? So why this offset is required? Because in a production line, we have so many pallets, we have so many fixtures, and in one fixture, we have different workpieces. No need to write separate programs. Okay. So just to change the offset so that we can use the same program. So this section is explaining the milling operations used in EMCO Concept Mill. One is downcut milling, then upcut milling, then downcut slash upcut combination milling. So what is milling? Milling operation. Milling operation means in the milling machine, to remove the material, milling cutter will rotate and the workpiece will give you the feed. So based on the feed direction and cutter rotation, the milling will be classified into downcut milling and upcut milling. So what is downcut milling? So downcut milling means tool rotation. So the tool rotation and the direction of the workpiece in same direction. Now you can see this is the rotation of the tool, right? So this is the rotation of the tool and the workpiece will be moving in the same direction. It is what is called a downcut milling. So here you can see the feed is to the right side direction and the cutting direction also to the right side direction. This is what is called a downcut milling. So how cutting is happening? So blade, first of all, the blade will enter into the surface of the workpiece and cut the workpiece, right? Blade enters immediately. So in downcut milling, the chip will be maximum thickness. Then after that, the chip will be the thickness will be reduced in downcut milling, so that you will get better surface finish because the blade will enter directly. So the surface will be smooth. Friction will be less because sliding is less, so that the heat will be reduced and also tool wear will be reduced. Tool life will be more because blade will be taking less time in contact with the surface. So the problem will be backlash will be a problem. That means small clearance. Because of this backlash, the machine will uh, uh, move quickly to the front, so cutter will damage, so or tool will break, and also the accuracy will be poor. Then coming to the upcut milling or conventional milling, we call it as conventional milling. So we have the feed direction. This is our feed direction, okay, and the cutter direction will be in opposite direction. It's called a upcut milling. So in upcut milling, the blade will touch the surface, then enter into the material. So the chip thickness, first of all, initially the chip thickness will be small, and after that the thickness will be more. So this is useful in conventional milling machines, and also it is used for hard material. But this upcut milling, friction will be more, so heat will be more, tool wear will be more, surface will be more rough. So downcut or upcut milling, it is the combination of both. So in a tool path, in some areas it will be downcut, in some cases, in some area it will be upcut. So in CNC machine, you will use downcut milling. So downcut milling means the feed, the movement of the workpiece and the rotation of the tool in same direction. So these two milling strategies are advanced strategies used in Sinumerik Operate Mill, EMCO, trochoidal milling and plunge milling. So these two milling technologies are used in the rough machining. That means to remove a large amount of material in the initial phase, trochoidal milling and plunge milling. Trochoidal milling means, so the tool will make, uh, circular motion as well as the linear forward motion. This milling strategy is what is called trochoidal milling. That means, uh, uh, so in normal case, the tool will be moving like this, right? The tool will be moving like this. Okay, so trochoidal milling means the tool will move like a small circle and also the linear forward motion. This is an advanced strategy to remove large amount of material during the initial phase. This is what is called a trochoidal milling. So that means the tool will move like a circle, then forward, right, again circle, forward, like that. So this is mainly used in roughing hardened materials, high strength materials. So roughing means we need to remove a large amount of material initially before the final finishing. That process is called roughing. So tool will be producing small circular motion and also it will move forward. So the advantage of trochoidal milling is that we will get more cutting depth than the conventional milling. So for example, in conventional milling, say the depth will be 2, but in trochoidal milling, you will get say 8 millimeter. You will get more cutting depth. And the next one is the cutting speed. The load is low in tool, so increase the feed speed. Then tool wear will be reduced because tool will use the full surface. Chip removal will be good. And also we will be easily remove the chips. Tool life will be more. So the generation of heat is very less. So we can use the tool. And also radial force will be because of the circular motion, side force will be very less. Okay, machine vibration will be less because the side force will be reduced, so that the machine will be stable, smooth. So this strategy, this is an advanced strategy used in tool steel, hardened steel, titanium, stainless steel, aerospace parts, mold making, etc. Then another one is called a plunge milling. So in plunge milling, so the tool will vertically enter into the materials. No side cutting. Okay. So that means the tool will like a drill. Okay. The tool movement will be like a drill. This is for, slots, pocket, unstable machine, thin workpiece. It is very useful. In conventional milling machine, the side force will be more, right? But in plunge milling, the force will be tool axis. So tool bending will be reduced because otherwise in conventional milling, the tool will be like this, right? So that means that there will be a side force. Because of the side force, the tool will bend. There is a possibility to bend the tool. But in this case, there is no side force. Okay, tool will not bend. And the vibration will be, workpiece vibration will be less. We will get more cutting depth. Tool life will be more. So this strategy will be used in deep pocket, slot, thin wall, weak fixture, long tool, large unsupported length, etc. So these are the advanced strategies when we will use in different CAM software such as Mastercam, Siemens, etc. So this is what is called a tool radius compensation. This is a very important concept in EMCO CNC machine, also other CNC milling machine. If there is no tool radius compensation, if there is no tool radius compensation, we will not be able to make the actual dimension parts. Because when we write a program, we will prepare a program based on the contour of the workpiece, right? But if we consider a tool, it is having a center, right? So when the tool is moving, actually the center line is moving. When a tool is running, that means the center is moving, but the tool is having a diameter, right? That means this radius, right? Okay, the tool is moving means, okay, this extra radius will be cut in the workpiece so that we will not get the actual dimension of the workpiece. So we need to compensate that radius. That is what is called a tool radius compensation. So for example, we have a milling cutter, okay, and we have an end mill. We have an end mill of diameter 10. That means radius 5. Okay, radius is equal to 5. So when the tool is moving, okay, the tool center is moving. That means if we will not consider this radius, okay, when we write the program, we need to consider this radius. If we will not consider this radius, this much portion will enter into the workpiece and that much portion will remove the material. So to compensate that radius is what is called a tool radius compensation. So for example, you are going to make a square machine. You are going to make a square machine pocket. And the tool diameter is equal to say 10 mm. Okay, so if the tool directly touches the boundary line, then what will happen? Then half of the tool will be inside the workpiece, right? Half will be outside the workpiece. We will not get the exact dimension of the workpiece. So that means when we run the tool, you should shift this 5 mm radius to this boundary, right? Okay, shift this 5 mm radius, right? If the tool radius compensation is off, okay, then the tool will move through the contour, okay, through the center line of the tool. The tool center line will be traveling like this through this contour. So we have a right hand tool radius compensation G42. The code is called G42. So tool will move to the right side. Okay. So control system will calculate the tool radius. So in the code, you should give the D01, that is the T radius offset number. Tool, then next is left hand tool radius compensation G41. It will travel to the left side. G40 is used to cancel the tool radius compensation. So next is tool data. This is a very important concept, tool data measurement. If we will not give the correct tool data, what will happen? Okay, we should give the tool data correctly. Otherwise, it will hit the, this is the workpiece. Otherwise, the tool will hit the workpiece, or we will not get the correct depth of cut, or it will damage the workpiece. So first of all, what do you mean by tool data? Tool data means the important informations related to a particular tool, and we will store all those information inside the controller. This is what is called a tool data. So normally we will use the tool number, then tool length, then what is the tool radius or tool diameter, then tool type, what is the tool type, and wear compensation. These are the important tool data we will store inside the controller. So the objective of tool data is to control should use the tool tip or the tool center point for positioning, not the tool mount reference point. So tool holder reference point. So this tool holder reference point is what is called a N. So machine should know what will be the length from this N to the tip of the tool. Say for example L1. This is what is called a tool length. This is called a tool length. From the N to the tip of the tool. That length is what is called a tool length. Every tool used for machining must be measured. For example, we have a tool number 1, T1, and it is end mill, and the length is 85.20. We have another tool T2, so drill, so length is 102.50. We have another tool T3, phase mill, 78.40. So now you have 3 different tools, right, with 3 different length. So we should store these 3 length inside the controller. So this length will be measuring from N, reference point, from the reference point to the tool tip. From the reference point to the tool tip. That is what is called a tool length. That is what is called a tool length. So why this tool length is required? Just imagine you have 2 end mill. So one length is 80 and the second one is 120. Okay. See, one is 80 and another one is 120. If the controller don't know the tool length, then it will hit, the tool will come and hit the workpiece. So inside the controller, we should, for example, if you will be using a tool, you should enter the length and also the radius. For example, you have a tool number 1 and the length is 85, radius is 5. Then you have a tool number 2, 100 length and 6 mm radius. Then you have a tool T3 of length 76.20 and radius 3. So this tool radius is not mandatory for all the tools. Tool radius should give when you use tool radius compensation and milling cycles. So select the tool, right? The procedure will be like this. Then measure the tool length, then measure the tool radius, and then tool data, then tool offset. Then after that, you can start the machining. So here I'm going to discuss the key description. So what is the use of different buttons used in this controller? So here we have so many keys. For example, reset, NC, start, stop, machine, jog. There are so many keys. Depending on the machine you are operating with the Sinumerik Operate, not all functions and machine buttons may be available. It will change based on the machine model. The buttons will change based on the model you are using. So this is EMCO WinNC for Sinumerik Operate Mill. So this section is going to discuss the different keys. Before operating the machine, you should understand what is the use of different keys in this machine. Using these keys, we can control the machine, we can prepare the program, we can run the program, we can give the tool offsets, work offsets, machine homing, we can check the alarms, etc. But remember, based on the type of the machine you are using, not all functions and machine buttons may be available. So the buttons and functions will change based on the machine model. So first of all, we have the Sinumerik Operate control keyboard. This is the software keyboard. Using this keyboard, we can prepare program, select the tool, move axis, and run the machine using this keyboard. What is this easy to control? Easy to control. Easy to control means this is the compact CNC operator panel developed by EMCO. Easy to control so that you can easily control it. For that, you have physical keys, hand wheel connection, feed override, spindle override, axis selection, NC start, stop. Everything will be here. So the advantage of easy to control is that we can use the machine very easily. And also with the help of this, training will be very easy. So this will give a feel, exact feel of real Siemens controller. And also we can safely use the lab because this is an industrial environment, right? Then next is MOC touch. MOC means machine operation control. Machine operation control touch. That means this is a touch screen interface. Using this, we can touch the screen and we can operate the machine. We can select the soft keys, give tool data, edit the program, change the offset. Without using the mouse, by touching the screen, we can operate this. So when you operate this machine, you should use easy to control plus this MOC touch. MOC means machine operation control touch. So next we will check machine. So this is MOC touch. So yeah, this is MOC touch. That means machine operation control touch. That means this is a touch screen interface where you can touch. This is a touch screen interface. Okay, you can choose machine program, program manager, you select menu, user menu, custom offset program. So you can choose, this is a touch screen. That's why this is called a uh, MOC touch. MOC means machine operation touch control. So this section, I'm going to discuss keyboard keys and its use. What is the use of each and every button used in this machine? First of all, we have one address and numeric keyboard. This is to write the CNC program and edit the CNC program. So using this address and numeric keyboard, we can give XY coordinates, provide G codes, N codes, read rate, spindle speed, tool number, everything we can type. So everything we can type using this address and numeric keyboard. Suppose you have one button with two functions. So by pressing the shift key, so by pressing the shift key, you will get the second function. This will be exactly similar to the shift key in our computer. So below the screen, we have different soft keys. Okay. So if you press the soft keys, you can go to the next page. By pressing these keys, you can go to the next page. You have different keys below the screen. Below the screen, you have different keys. By clicking this, you can go to the next pages. Then I'm going to discuss what we call the button functions. You can see the functions of each and every button. So, for example, we have a machine button. So here you can see we have a machine button. So if you press this machine button, it will directly go to the machine operating area. So if you press this M, now you are in the machine operating area. So in the machine operating area, you can see the job, right? You can see the job. Then you can see the job reference point. Then spindle, coolant, axis movement, you can control. Then we have parameter button. So go to machine. Yeah. So go to menu select, you can see the parameter. You can see the parameter where you can see the machine parameters such as tool offset. Yeah, right. So go to work offset. So G54, 55, 56, you can see. So we can select and parameter, or you can change all those settings. Then we have a button called a program button. So when you press this program button, it will when you press this program button, it will open the program editor. This is what is our program editor. Here you can add new programs, or you can edit program, or you can save your program. For example, this is my program. Here you can edit, save, etc. Then we have another button called the program manager. Program manager button. Select this program manager button. In the program manager button, you have all the programs. You can copy, rename, delete, or if you want to copy paste from USB. So everything will be in this program manager option. Everything will be here in the program manager option. Then we have a diagnosis button, right? So that means alarm. Just press the alarm where you can see any alarms or any messages or anything. It will be shown here. You can check the error, input, output, etc. using this. So then you have the back button. So right now you are in a screen, right? Uh, for example, program manager. So by clicking this button, you can go to the higher level, or we call it as horizontal soft key. Okay? Just click this, you will get more options. Then we have our menu select. This will open the main menu. So click this menu select. This will be our main menu. If you press this once again, it will go to the previous operating area. If you press menu select, you will get the, for example, machine parameter or program manager, diagnosis, startup, reference point. Okay. If you press this menu select once again, it will go to the previous operating menu. So next you have a menu function and menu user. So here there is no function actually. Menu function and menu user, there is no use. So in this machine, there is no function to these uh, menu function and the menu user. But in some other Siemens machines, those functions will be enabled. But in this machine, there is no function to menu function and menu user. Then alarm acknowledge. So this alarm cancel deletes acknowledged alarms to clear the alarms. now you are here, right? So again, this is the automatically show the diagnostic cycle of the failure. So now you are here, right? With this help. Okay. It will automatically shows the question. That's how you are your program. It will automatically help you in the topic. How to this program. It is very much useful. Context sensitive help. For context sensitive help. Then we have another option called next window. So next window means if in your screen you have more than windows. Next window will select the next window. If you press the button, the selection will change. Then channel. So in this case, there is no use, right? So this is not used in EMCO Concept Mill 260, but in big machines, it will be using. But in EMCO Concept Mill, it is not using. This is not using. So next you have a cursor right. Okay, so this will be used when you will use a program. So for example, your cursor is here, right? So you can move your cursor like this. So using cursor right, left, it will move the character. Cursor right will move to the right side. This will be used to edit the program. Cursor left, again to the left side. So you have the cursor up, right? So you have the cursor up, down, left, right. So this will be very much useful when you will edit a CNC program. Then you have a backward and forward to go to the previous page or next page. For example, in the program manager. So go to program manager. Okay, so page down, page up. So to see the previous page or next page, you can use this. And space key is used to provide a space. Again, this also will be useful in when you will write the program space. When you have this backspace key will delete the character on the left side. So for example, you have a program. So you have a program, where is the program? Go to program manager. Yeah, this one open. Okay, so for example, this M3. So if I press backspace, it will delete the character on the left side, backspace. So if you press this backspace, it will delete the character on the left side. When we have a navigation, then next we have DEL, delete mode. So delete mode will again delete the character on the right side. So for example, we have this one. Okay, just 120. If I press this delete, okay. So if I press this delete button, it will delete the right side character. So this backspace and delete, it will be used in preparing the program. Okay, when you prepare the program, it will be useful. Then next is the selection button or a toggle button. This is very important button to select the input field. Okay, if you are going to select a particular program, okay, go to program manager. Okay. So for example, if you want to select this program, just facing the mode to press this select button. So insert button or edit button to edit a particular value. Jump to line end. It will go to the end of the program. So this button, enter, next is the enter button. This is the most commonly used button to, for example, edited value cell. For example, you have a feed value 100. You need to change this to say 150. So change this to 150. Now then press input. And also, for example, you have a program. Okay, just press this input. It will open that directory, that folder. Okay. Or if you want to open a particular you know, so if you press the input, it will open. Also, you can change the values. Shift button is to use the second function. For example, in a key, you have two different functions. If you need the second function, just press the shift, you will get press the shift and press that button, you will get the second function. This will be exactly similar to the computer keyboard shortcut. So these are the different shortcuts to copy. Control C, paste, Control V, Control X to cut. Repeat input, Control Y, Control C, undo, Control A, select all. Control plus next window, go to program start, Control End, go to program end, Shift end, mark to end of block, Shift next window, mark to start of line, Alt plus next window, jump to start of line, Box skip reset, close WinNC for Sinumerik Operate. Okay. So these are the some basics related to this. So the next session, I will discuss the screen layout. And after that, we will explain the operation. Then we will start. We will start the short mill programming. Then we will discuss different cycles. Okay. Thank you.